All right, so we are starting a new unit today. This unit will take us pretty close to, if not all the way to spring break. We could probably make it last long enough to get us at least pretty close to spring break so that we can have some more summatives on our quarter grade. That would be a good plan. I like that plan to have that plan. Step into the screen here. So yeah, so we got that going. It is going to be on sequences and series. I will tell you right from the start that last week the A groupers, those guys over there on the screen, chose to take today's notes and break it up into 2 days. Okay? So there is a video for you to watch tomorrow. Okay? It is a very important video for the entire unit. Okay? There's a lot of terminology and a lot of introduction to or reintroduction to some very key concepts in that video. It's not very long. It's under 15 minutes, but it's a very important 15 minutes. Okay? It's a 15-minute video that you definitely want to take notes on while you're doing it. Okay? Okay? So that will be for tomorrow. So tomorrow you got about a mod's worth of stuff to do in class for this class, even though we don't technically have class. Okay? All right. So let's talk about this. This information is out of chapter 12 in your textbook, and I actually stole this screen out of your textbook. It's on page 794 if you wanted to use it, but by no means do you have to. Yeah? So a sequence is is a list of patterned numbers. Okay? So it's a list of patterned numbers. 1, 2, 3, 4, 5, 6, 7. That's a list of patterned numbers. We're always increasing by 1. Okay? So that's a list of patterned numbers. 1, 4, 9, 16, 25, 36, 49. That's a list of patterned numbers. These squares, it's the list of the squares. Okay? And there's many different possible lists. Okay? So a sequence has what is called a rule. And a lot of the times the rule will be, back out there. A rule is going to be some kind of a function. Okay? That is going to be what's called the rule. And the rule is going to allow you to find any specific term. Okay? So if the rule was 3n plus 8, and you needed to find the 15th term, you would plug in 15 in for n, and that would give you the 15th term. Okay? So that would be like the rule. Okay? The values in that, or the values of, or the individual numbers in our lists are called the terms. Okay? So a sequence has a domain and a range. The domain would be the term number. The range would be the actual terms. Okay? There are two different kinds of sequences. there are finite sequences and there are infinite sequences. A finite sequence stops. Okay? It's got a specific amount of terms. Okay? 1, 4, 7, 10. That's a sequence where we added 3 every single time to get the next term. It's got 4 terms. It's done. Okay? Now, if that pattern continues on forever and ever and ever, then that is called an infinite sequence. And you can definitely tell an infinite sequence by those 3 dots right there. Okay? If there's 3 dots at the end of your sequence, that is telling you that that sequence is going on forever and ever and ever. Okay? And it won't stop. Okay? If it's just like this, or it might also look like that, where you still have the 3 dots, but then after the 3 dots there's a term, that's still a finite sequence. The 3 dots does not necessarily represent an infinite sequence. It just has to come at the very end of your list. Okay? We talked about the rule already. Love it. Okay? Write the first 4 terms of the following sequences. Well, here's rules, or here's functions, if you will. Depends on how you write them. If you write it like this in number 1, it's a rule. If you write it like number 2, it's a function, and that's fine. We can still have that. We can have either one, but we can create a sequence from it. So if I'm writing the first 4 terms of the sequence, the first term, I am going to plug 1 into my rule or function. So that would be 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7. So my first term is 7. Then I go to the next term. My second term, I'm going to plug 2 into my rule. 2 times 2 is 4, plus 5 is 9. Rinse, lather, and repeat. So the first 4 terms of the sequence is 7, 9, 11, and 13. Okay? And in a sequence, terms are separated by commas. Yes, they have to be written in that specific order with commas in between them. Otherwise, it's just 4 random numbers. Okay? And not necessarily has an order to it. Sequences have order. First term, second term, third term, fourth term, fifth term, so on and so forth. They have a specific order because that follows the rule, that follows the pattern. Okay? Over here in function notation, same thing. If I put the first term in, or to find the first term, I'm going to put 1 in to my function. 1 minus 1 is 0, and so negative 3 to the 0 power is 1. Negative 3 to the 2 minus 1 power, 2 minus 1 is 1. Negative 3 to the first power is negative 3. Three minus 1 is 2. Negative 3 squared is 9. 27. So again, this one would be 1. This sequence would be 1, -3, 9, -27 as the first 4 terms. That's a bad 7 now. As the first 4 terms of that sequence. Okay? Good? Or good? All right. Try that. Find me the 4th, the 9th, and the 32nd terms of each of those sequences. 4th, 9th, and 32nd terms in those sequences. So to find the 4th term here, I'm going to plug 4 into my rule. -2 times 4 is -8, plus 4 is -4. To find the 9th term, I'm going to plug 9 into my rule. -18 plus 4 is -14. And to find the 32nd term, I'm going to plug in 32. -2 times 32 is -64, plus 4 is -60. So when I give my answer for these, I have to give them, since it's not technically an ordered sequence because we jumped around, I would have to say that the 4th term is -4. The 9th term is -14, and the 32nd term is -60. I'd have to label each of those terms as to what they are. Just giving me those numbers in random order would signify then that they would be the 1st, 2nd, and 3rd terms in your sequence, and then they would have a totally different rule. Still wouldn't work out because I would have the ... wouldn't, I wouldn't know how many terms would be in there. Okay, and since we were asking for a specific term number, we have to just give the specific term number. As a sequence? I would still list it out like this. Yeah. Yep. So over here, my 4th term is going to be 4 over 4 plus 1. My 9th term is going to be 9 over 9 plus 1. And my 32nd term is going to be 32 over 32 plus 1. So that is 4/5, that is 9/10, and that is 32 over 33. So again, I would write that out as my 4th term is 4/5. My 9th term is 9/10. And I'm going to scroll down just a little bit. My 32nd term is yeah. So sequences can have fractions in them, they can have positive numbers in them, they can have negative numbers in them, they can have 0 in them, they can have 1 in them. Whatever, if there's a number that you can think of, it can be in the sequence. Okay? So let's take a pause here now and let's work backwards. So commonly, when we see these type of problems, describe the pattern, write the next term, and write the rule for the nth term. So there's 3 different things going on here in this particular problem. So first off, it says to describe the pattern. That would be in words. If you see that direction, describe the pattern, I would want to know in words what the pattern is. Okay. Write the next term. That is going to be a number. And because all the terms are numbers, so that would be a number then. And we would find it using the pattern that we saw in the first part, we would find the next one then. Okay. And write a rule for the nth term. Okay. So this is going to be an equation of some kind. Okay. All right. So looking at number 5, we've got here, now let me move this up a little bit, and this up a little bit, make it a little bit bigger. Okay. So the pattern, or the sequence is -1, -8, -27, -64. That is our pattern. Okay. If it were me, I would describe the pattern here as negative, because they're all negative, cubes. Because -1 cubed is -1. -2 cubed is -8. -3 cubed is -27, and -4 cubed is -64. Okay. Is that the only pattern? No, but that's one of them. Okay. And it holds for all of them. Your pattern, if you're describing it, your rule, if you're writing it, has to work for every single term. It can't work for just one term. It's got to work for every single term. Okay? And so that pattern works for every single term. Okay? So then my next term would be, so we went for 4, we got the first 4 terms, so then it would be -5 cubed, which would be -125. Writing a rule then for it. There's the rule. Negative term cubed. Okay. Based off of that, what I would like you to do now is I would like you to describe the pattern, write the next term, and then write me a rule for any term on number 6. So there's the answers to that one. Okay? So, going forward, I handed out to you guys here in class. Last week, in-personers got it. On Thursday, at Homer's full-on virtual kids, you're going to have to download it off of It's Learning. This week's worksheet. Okay? I'm sorry it's 18 problems, but we just have a bunch of different styles of stuff going on here, going on this week. So it's a little longer than what I like, but it's roughly the same amount of time into it. Okay? Problems more, yes. Time investment, the same. Okay? There is a video to watch tomorrow. Again, watch that video. It is less than 15 minutes. It will explain a lot of, it's talking about series. So there's sequences and series. We talked sequences today. Tomorrow I'm going to talk, or on the video we talk about series. There is a difference between them. It is a small change, but it is a change and it means a whole heck of a lot. So please watch that video for tomorrow. Okay? That's all I got for you today. If you haven't finished last week's homework, get that turned in. You can utilize this next mod to turn that in. If you haven't finished your the part B of the test yet, and you still got 1 or 2 problems to do on it, this would be a great time to do that. If you haven't started part A yet, don't start it now unless you don't have a class for the next hour. Okay? Part A is online and there is a time limit on it. Part B is not a time limit, but it's also online. Turn it in. Okay? I'm roughly at about 50% right now, which is not good. Okay? And those are all late now, so they're all 10% off. Okay? In terms of this week's homework, you can do 1 through 6 on this week's homework as of right now. Okay?